Now let's learn about inheritance. It is the first key principle. Inheritance is purposed for reusing common functionality. So we'll understand this with the help of an example. So suppose we have a class car. Okay, it has a functionality drive. Okay, so this class drives. Okay, now with the advancement of technology, we have cars with gears and we have cars with automatic cars. Okay, so they have something is different between these two cars, but still these two cars drive. Okay, so what we have two different kind of new technology car. This is manual transmission, I'm writing T, manual T class, and this one is automatic T class. Okay, so these two cars drive. So this drive functionality is inherited from the parent class to the child class. Okay, but they have some of their additional functionalities like transmit, step up the gear, step up gear, for example from 1 to 2, 2 to 3, and similarly it has step down gear from 4 to 3, 3 to 2, 2 to 1, like this. Okay, now automatic car in this transmit functionality is there, but transmission is automatic. So you cannot do step down, step 1, it will do on it itself. So no need to have any step up or step gear methods here. Okay, so these two classes can have their own functionality, but the common functionality which was there in the drive car, that is inherited from the parent to the child to both of these classes. And not just functionalities, the other properties that we had, color, model, and year of manufacturing, all this is also inherited from the child parent to child class. So you know it helps us avoid duplication of code. So if there is a code which needs to be present in many places, better we create a parent class and place it at one place, and all the child classes can use the parent class. And so let's go and implement this design in code as well. So as you can see, our car class has color, model, year, and it has this method as well, display info. Maybe we implement one method here, void drive, and naming convention method to start with small letter. And here we can say maybe we simply output a message driving. Okay, so this method is there. Okay, now we have this car class. Now we'll create two child classes of this car class. Okay, so we will say create one as manual transmission car. Now this manual transmission class will extend our car class. Okay, so as soon as we add the extends keyword, now whatever there is in our car class will automatically be inherited by our manual transmission class. But this is showing a red method here. Why is it showing a red method? Because if you check the error message in the problem, it is saying there is no default constructor available for cars. But basically what it wants is, in Java there is a concept of constructor chaining. What is there is, I will create a constructor for this class, manual transmission public, and I will call super dot. So when we will initialize this manual transmission car, when we used to initialize our car class, we used to give the color, model, and year. So we need to give these properties to in this car as well. Okay, so we need to go to our manual. We already agreed that there is no point of creating a car without the color, in model, and year. And now we cannot see these properties here. So how would we initialize? When we were writing the car class constructor, we used to see these properties. So we used to be able to initialize that. But now what to do in manual transmission? How will we initialize that? So we will call super and we'll pass in these arguments. We'll pass in these arguments one by one. Okay, now you see all errors have gone away. Now what does super do? Super basically calls the parent constructor, and there is a default rule in Java that first line of a constructor, the rule is that first line of a constructor should call the super constructor. Okay, so if you don't add it manually, it will, Java compiler adds it for you. but it does so only in the case of no arguments constructor. If your car has a no arguments constructor and you create a no arguments constructor for your manual transmission car, in that case, even if you don't call super, Java will compiler will add that super call here. But since we have our multi arguments constructor here, we have to first line should be a call to super. Okay, so using this we can call super, and now we can have methods here, public step up here. Okay, so maybe we write system dot out dot println stepping real public void. We missed void. Void is a return type. Without void, without specifying the return type, you cannot define a method. We can also have step down gear. Okay, and let's take one more method, which is transmit. So this transmit will actually call these step up and step down according to the requirement. So we simply say managing transmission. Okay, now let's create one more car, which is automatic transmission. Okay, so again this will also extend the car class. It will get the drive method by default, and instead of writing the constructor, what I can do is there is a shortcut which says in IntelliJ you need to go to code and then you need to go to generate constructor. Okay, and we will use the 3 argument constructor of the parent class, which is car class, and we click OK. You see it has generated a similar constructor for us as we implemented there. So this one also has the transmit method. Okay, and it says no rounds required. So this is the implementation for the automatic class. So both of these classes are extending our class. Okay, so now let me show you a couple of things. Suppose I'm creating a new car with anything car example. So this car example class, again I need the main method. I'm just copying the signatures in order to saving the typing. Okay, I have the main method now. So here I'll create the car object. So what I can do is there are two ways. I can say manual transmission car, man car is equal to new manual transmission car. I need to give color which is black, model is this manual, and year of manufacturer is 2024. Okay, so I can do this. Similarly, I can do for automatic as well. Automatic transmission car. So I'm saying automatic car. And so I can create these two objects as well. Now you see if I just go and type man car dot, I am getting step down gear method, step up gear method, which is specific to manual class. But I am getting display info method, which is there in the car class. It is not even there in the manual transmission class. I'm getting the display info. I am also getting the drive method, which is again not in these two classes. It is there in the car class. Okay, so I can call display info. I can call drive as well. Similarly for auto car also I can call display info. Then I can call drive as well. Okay, let's place a debugger in. Debugger is already there. Let's place a debugger in drive also. Okay. Now let's test this code. Okay, as soon as I debug this code, let me put some more debug breakpoints. Great. Okay, so when I click on resume button, watch carefully where the flow of the program goes. Okay, it is going to the constructor of the manual transmission car. Then there is a call to super. So then it is going to the constructor of the car class. So it will continue to go till the top hierarchy, and then after all the constructors are called, then only the object of that class will be called. Suppose car would have also been extending any other parent class which is vehicle, then it would have gone to the vehicle constructor as well. So it will go till the top and then only it will initialize, because everything in the hierarchy should be initialized. So it has gone to the car class. Now it is initializing all the 3 properties. Then it will come back and then manual car object is created. Now if I call display info, again display info method is present in the car class only. It is not even there in the manual car class. So it is calling the parent display info method, and you can see that it is displaying the required result as well. Okay, similarly for drive method also, it will go and it will print drive as well. Okay, Now it has gone to this line and it has again call the constructor for creating the automatic car object. You can say again, then display info, then drive. You see, this one again, second time has been printed for automatic car example. Maybe we change the color to white so that we can, and of course, this should be automatic. If you run it again simply, you can see that display info first time has been called for manual car, second time has been called for automatic car, and drive method has been called for both of them. Now you can call specific methods which are there in these classes as well. For example, man car has step up gear, man car also has step down gear. Okay, man car also has the transmit method. Okay, you can call the transmit method which is there in auth car as well. So if I run this code again, you can see here stepping up gear is called, then stepping down gear is called, then managing transmission for manual transmission is called, and for the automatic car no transmission required is printed. Accordingly, appropriate methods have been called. Now one more thing, since this transmit method is there in automatic car as well, it is there in manual car as well. Okay, so can we do something to make it? So one more thing to observe here is, here you have called manual car, man car, and then you have created a manual car object. But you can also simply do car. And now since this transmit method is common in both these classes, we can generify this transmit method as well because it is there in both the classes. So what we can do is we can create an interface. So we click on Java class, but here instead of class choose interface, and I'm creating this interface as transmittable. Okay, interface. So this is an interface, this is not a class. You cannot do new and create an object of this interface, it will not allow you to do. So this is used for segregating common functionalities. So two of our classes had the transmit method. What we can do is we can add this transmit method to this transmittable interface. In interface, you don't need to implement the methods. These only serve the purpose of forcing classes to implement these methods. So since both the classes have transmit interface, what I can do is, suppose for some time if I remove this method, I remove this method in both the classes. Okay, and now I want my class to have this transmit method, and there should be like something to force that you have to implement the transmit method, otherwise your code will not comply. To enforce some functionalities, if you want to enforce something, in that case interfaces is used. So what I can do is, to if I want to enforce them to implement the transmit method, what I can say, implements transmittable. As soon as I ask it to implement transmittable, it will give me a compilation error that you are not implementing one of the methods that is defined in this interface, and that is transmit method. You have to implement this method. So now having this method is like something that is being enforced on us to do. Earlier it was not enforced. So now, and if our automatic class car, similarly if our automatic transmission car also implements this interface, again it is also having a compilation method, or it is being forced to implement this transmit method. Okay, so you can only extend from one class, but you can implement as many interfaces as you want. Now comes the tricky thing. Let me show you. If I come to this car example, let me remove these step down and step methods. Okay, so let me remove this transmit method also as right now. Now this manual transmission and automatic transmission, instead of referring them using their actual class names, you can also refer them as car. So you see, here you are creating an object of type manual transmission, but you are referring it as a car, not as a manual transmission car. So this will also work. Everything will be same. All the functionality will remain same. You can see the same output is printed. So instead of car, you are referring it as manual transmission car. Okay. Because these two methods are available in the car and are inherited by car, you can refer it to this as well. But if you try to now call that step up gear, it will not show that method. You will not be able to call it because even though it is a manual transmission car, you are referring to it as a car, and car only has two methods: display info and drive. It doesn't even have the step info and step up gear and step down gear. It will not even allow you to run the step up gear and step down because it is not able to, because you are referring it to as a car class, even though it is a manual transmission car. Okay, and you can do one more thing here. Instead of referring them as car, you can also refer to them as transmittable. Now you are still creating the manual transmission car object, but you are referring to it as transmittable. So now it will allow you to only call one method, which is transmit. So if you run this method, you can see it has printed managing transmission for the manual transmission, which is implemented in the manual transmission class only, managing transmission. And as a next line, it has printed no transmission required, which is implemented in the automatic transmission. So you are not even referring those classes on the left hand side, you are calling them as transmittable. So you can refer an object using its parent class name, its actual class name, or any of the interfaces that class is implementing. But remember, if you refer them with parent class name, you will only be able to call the methods which are available in parent class. And if you refer to them as interface, you will only be able to call the methods which are there in the interface. Okay, so this brings us to our next concept, which is polymorphism. Polymorphism means one class can be represented in many types. Okay, so what you are seeing here is a manual transmission car can be represented as manual transmission car. It can be represented as car. It can be represented as transmittable as well. So you are able to refer an object in using different forms. This is called polymorphism. Okay, so this is the second OOPS concept. So polymorphism, it says one object can be referred as many types. So we have a manual transmission class. M1 is equal to new manual transmission class. So this is the first way. Then you can also do correction, it is car, not class. So this is the first way. You can call with the actual class name, but you can also do car M1 is equal to same. This is the second way. Third way is you can use the interface transmissible M1 is equal to. So this is, ability to represent an object in different forms is called polymorphism. Okay. Now we saw that in our car class we had this drive method. Okay, if I create a similar method in both my child classes, driving using manual transmission, okay, and I create a similar method in my automatic car class, transmission. Now if I refer these two objects as car and I call the drive method, which method will it call? If I control and click on this, it is going to the parent class drive method. Okay, so parent class also has the drive method. This is the car class, and this is the child class, manual transmission car. This also has the drive method. So which one will get called? Same method is present in both the places, and on the left side we are using parent name, and on the right side, and on the left side here we are using the. So suppose we have this display method in our parent class, we implement the same display method in our child classes as well. So in the child class we have written driving using manual transmission, and in the another child class, which is the automatic transmission,